Sorry for the mess here on 16, kids. This is what happens when you don't crop your photos. Okay, what's going on here? F is a function given by, we've got the definition here of a cubic, and they want the maximum value of f on this interval from 0 to 6. Okay, maximum values can occur at two places, critical points and endpoints. We've already got our endpoints right here at 0 and 6. We need to find critical points, which come from the first derivative. So f prime of x is going to give us a 3x squared minus 12x minus 15. That derivative will never be undefined, but I think it will probably equal 0 at least once, although I could be wrong. Let's begin nice and simple just by factoring out the 3. That leaves us an x squared minus 4x minus 5. Now I'm feeling pretty good about this. And then we'll do some reverse FOIL here, guys, and that's going to be an x and an x. Since that 5 is negative, 1 plus and 1 minus, and we need two numbers that multiply to negative 5 add up to negative 4. That's going to be a positive 1 and a negative 5. We'll set that equal to 0 and solve. Here, we're going to get a critical point at x equals negative 1, and here we'll get one at x equals 5. But you always have to pay attention to your interval here, guys, which in this case is from 0 to 6. So even though negative 1 is a critical point, it's not relevant to us at all on this interval here from 0 to 6. We can throw it out. So the only critical point we have to consider now is that of x equals 5. Yeah, we don't want to make any assumptions, although I think I know the answer already. We're going to go ahead and test the function, the original function, f, at each of these three values. So our left endpoint is 0. The one critical point we have to worry about is 5. And the right endpoint then is 6. And of course, this is a non-calculator question, which makes things just a little bit difficult. But here we go. Plugging the 0 in. Okay, that wasn't difficult at all. F of 0 is 0. Plugging in a 5, let's think about that, guys. F of 5 is going to be right here. 5 cubed is a 125 minus, all right, 5 squared is 25, and 25 times 6 is 150. Gotcha. And then minus a 15 times 5 is 75. Now, this one isn't too tough to come up with the exact value for, although it might not matter that much. Let me come back to that idea in a moment. 125 minus 150 is a negative 25. Minus 75 is going to get us a negative 100. That's a pretty low value right there. But let's try to find f of 6 now and see how that compares. 6 cubed, hopefully you know that. It's 216, and if not, you could probably come up with it on your own just by multiplying 36 by 6. But the fun part now is, guys, minus 6 times 6 squared. That's the same thing as 6 cubed. So whatever number you came up with right there, it wipes itself out, and you're basically at 0. And then minus 15 times 6 is going to be 90, and we're going to end up with a negative 90 for our answer right here. So I take back what I was about to say a second ago. You actually kind of did need the exact values right here. Now the question here is, everybody, let's read it carefully. What is the maximum value of f on that interval? So we look at these three y values right here, and we pick the maximum. And this doesn't happen that often, but that, everybody, is 0. So the maximum value of 0 means that our answer here is A. What I was going to say earlier, and I think I'm glad that I didn't, is that we can tell by this function here, because it's x cubed, and then minus a 6x squared. This is a positive cubic function that most likely has a dip in it and does something like that. What you don't really know here, everybody, is where the 0 and the 6 come into play. With two critical points right here, I'm pretty certain that this peak right here happened at x equals negative 1, and this trough right here happened at x equals 5. So I know then that 6 is going to get me a point right over here, and 0 would probably get me a point right over there. So what I'm really looking at is just this portion of the curve right here, and if I drew this accurately, that kind of supports that this spot right here would be the peak value, but there's a lot of assumption involved in there. We don't actually know that this point wouldn't have been higher than this first one. So obviously, we want to do this problem properly and not just make assumptions. So that's how we do it. Find your critical point, evaluate the function at both endpoints and your critical point, and then take a look at your three y values and determine which one was in fact the minimum.